Hi girls, so this video is on equilibrium constants, how to work them out, and also how to work out the units for equilibrium constant. So to begin with, I'm just going to look at question 17.3 in your textbook on page 280. So these are just a few examples of equations that you could be given and you're asked to find the equilibrium expression or the equilibrium constant for them. So sometimes you will be given values and you'll have to work out a specific value for the equilibrium constant. But in these equations here, you're just working out what's called the expression. You'll see what I mean in a minute. But the first one here is part A gives us the equation 2CO plus O2, and it goes to 2CO2. So when you're writing equilibrium constant, it's always your products over your reactants. So you write Kc is equal to your products over your reactants. So your products are always the right-hand side of the equation. Now, there's a few really important things when it comes to writing the equilibrium constant. One of them is that you always have to use square brackets. So these square brackets represent moles per litre. And you will lose marks in an exam if you don't have those square brackets in when you're writing the equilibrium expression. So you can see here that I've left out this big 2 in front of the CO2, and that's because when you're writing it into this formula, the big number in front of your species goes to the power of. So this one becomes CO2 to the power of 2 because it has that big 2 in front of it. So that's our products. And then on the bottom we have our reactants, and these end up being multiplied by each other because there's a plus in the middle of them. That turns into a multiplication. So again, we're using our square brackets. We have CO, and this one again is to the power of 2 times oxygen, and this is just a small 2, so we leave it where it is, and it's not to the power of anything because it doesn't have any big number in front of it. And that is our equilibrium expression for that reaction. So again, 2 really important things to remember is, well, I suppose 3 things to remember is that it's always products over reactants. We always use square brackets, and if there's a big number in front of the species, it goes to the power of in the equation. So let's have another look at another example. So again, looking at the same question in part B, it gives us the expression or the equation C2H6, which decomposes into C2H4 plus H2. And again, it's the same question. We're asked to write the equilibrium expression for this reaction. So again, we're going to say that Kc is equal to our products over our reactants. So don't forget your square brackets. So that's C2H4, and it's not to the power of anything because there's no big number in front of it, times H2. So again, that plus becomes a multiply, and it's not to the power of anything because there's no big number in front of the H2. And then beneath the line we have our reactants. So again, our products are always on the right hand side of the equation and our reactants are always on the left hand side. So this just simply becomes C2H6. Again, not to the power of anything because there's nothing in front of it. So that one was an easy one. And don't forget your square brackets. So we'll keep going. The third one in that question then is NO2, which breaks down into a half N2O4. So again, our Kc or our equilibrium constant expression is going to be our products over our reactants. So N2O4 to the power of a half over NO2. And that is it. And I'll do one more, last one in this question. gives us CO plus H2O, and it turns into CO2 plus H2. So again, products over reactants, Kc is equal to square brackets CO2 times H2 over square brackets CO times H2O. Okay, so again, 3 things to remember. It's always products over reactants, always use square brackets, and if there's a large number in front of a species, that species then goes to the power of whatever that number is. So they are the 3 key things to remember when it comes to writing the expression for an equilibrium constant. So the next thing I want to talk to you about is units. So the units for equilibrium constant can change depending on what exactly you're looking at. So let me see, we'll pick out an example here to have a look at. So let's see, if we take the example here, H2 plus I2 goes to 2HI. So in order to work out the units, we'll first work out the equilibrium constant expression. So again, Kc is equal to square brackets HI to the power of 2 over H2 times I2. So that's our equilibrium expression. Now, I mentioned the square brackets before, and they're really important. You will lose marks in an exam if you leave them out. The reason they're so important is that they represent moles per litre. So these brackets are actually telling us what our units are. So in this case, because the square brackets on top are squared, it's the same as having moles per litre times moles per litre. On the bottom then, we have 2 square brackets, or 2 sets of square brackets, and each of them represent moles per litre as well. So this is the same as having moles per litre times moles per litre. And as you can see then, these are all going to cancel out. So this is moles per litre being divided into moles per litre. They cancel, and the same thing over here. So for this reaction here, there's actually no units for the equilibrium constant. So as you'll see then, we can look at a different example where we will have units. So let's have a look at another example. So we'll take the one for ammonia. So N2 plus 3H2, which goes to 2NH3. So let's write our Kc, or our expression for equilibrium constant. Again, our square brackets NH3 to the power of 2, because of the big number in front of it, over N2 times H2 to the power of 3, because of this 3 here. So on the top, again, we have square brackets squared. So that's moles per litre squared. So we can write that out up here. That's the same as having moles per litre times moles per litre. And on the bottom then, this square bracket here represents 1 moles per litre. So I'll try and write it in small, moles per litre. And then we have a set of brackets here to the power of 3. So that's going to be moles per litre to the power of 3. So I'll try and squeeze this in. Moles per litre times moles per litre. So let's lift this up so you can see. what I have here is 2 moles per litre on the top and 4 on the bottom. So 2 of these are going to cancel out, but we're still left with 1 over moles per litre squared. So the units for this expression of Kc is going to be 1 over moles per litre to be squared. And that is how you work out the units for an equilibrium constant. So I'm going to go through a few more examples now, and they're going to get trickier as we go along, and I'll work out the units for each one of those. So we'll see this again in a minute. So we're now going to look at example 17.3 on page 275. So this is example 17.3 on page 275. So the reaction is actually the same as the one we just did. N2 plus 3H2, and it goes to 2NH3. So it's asking us to find